Okay, we're going to continue our review of the problems with the energy bar charts. Scenario number 3. We start with a piece of clay resting on the floor, and that's where we see it. Okay, so here is our energy bar at A, and there's nothing. There's no gravitational potential energy because it's at the low point. There's no kinetic energy because it's not moving. And there's no elastic potential energy because it's not squished or stretched. It's just a lump. That's why it's not round. Okay, but now as we transition from A to B, we find that B, it has gravitational potential energy. And there it is right there. Okay, so just working a little backward. If we look at B, I'm kind of arbitrarily saying that there's 4 blocks. We could have said 3 blocks, 5 blocks. Just there's an amount of energy, gravitational potential energy in the system now because the clay is elevated. We have to account for how that energy got into our system, and the way you're going to show that is between A and B, work is done raising the piece of clay up from its low point to its maximum peak height A. And at B. So at B we see it's not moving, so there's none of that energy went into kinetic. It's not squished or stretched, and there's no E dis, not yet anyway. So this gets us to B. Now the ball is dropped, or the ball of clay is dropped, and it begins to accelerate downward. It starts to move. And we also see that at C, it is about halfway down to its low point. So, but no work is being done. So we're going to say that the total energy at C equals the total energy at A. And we're going to say that the gravitational energy has been cut in half. So that means there's 2 blocks of energy that are, we could say, missing, but it's somewhere else. It's transformed. And it's going to be kinetic energy. Now, it continues to fall until it splat. The clay hits the ground. And what we're going to find is that the ground is a little bit warmer underneath the clay, and the clay itself is a little bit warmer. So there is still, the energy was not destroyed. There's no kinetic. There's no gravitational. There's no elastic potential. So it's all E dis. The key point is once the energy is in your system, unless it does work on something, and the amount of energy stays the same. And what we're doing is we're calling that smack against the ground not work, but it's just all that mechanical energy that was in the system now has gone into thermal energy, which will now dissipate out into the universe. Okay, scenario number 4, we have a pendulum bob that is initially at point A, and that is at the low point of its motion. So we're going to say that at A, it has no gravitational potential energy. It's also not moving, and there's also nothing spring-like that is noticeably stretched or squished. Okay, so there is going to be no energy at A, but then work is done raising the pendulum bob from A up to B. And we're going to say that that work was 4 blocks. So now at B, it's at its high point, and it's not moving. So we're going to say those 4 blocks of work went into 4 blocks of gravitational potential energy. Okay, now the pendulum bob is released, and it's going to swing back down through A, back to the low point. But now it has energy, which it did not have at A, so we need to account for that 4 blocks of energy. Well, it's at the low point. Well, there's the idea. So the energy is in the system. We have to account for it. Well, it's at the low point, so there's no gravitational potential energy. Where'd the energy go? It is all kinetic. Okay, and then now it's moving up to D. It's gaining height. But the total amount of energy is not going to change. So it's halfway up to the top, so there's now 2 blocks of gravitational potential energy. So that means we're going to have to take 4 of these blocks. Okay, so 2 of these blocks have now just gone into gravitational potential energy. Guess how many are left? That's right, 2. Okay, and then it keeps going. It's going to go all the way up to point E, back at the same height as B. So it's going to have all that gravitational potential energy. And guess how much kinetic energy it's going to have? None. So that is it. There is no kinetic energy. Okay, we're going to stop that, and that's problems 3 and 4.